Hello, most respected and dear Eulerians. Today we continue our series, which are dedicated to Project Euler. And I'd like to say hello to Yegor Gorbachev and Ivan Safonov. And especially, what I'd like to say hello with is with what I will do next 10 minutes. So, maybe you noticed that during the previous stream, I stopped on this problem. This was because it needed to read a lot of 50-digit numbers and to sum them up. However, in C++, there is no standard mechanism of reading and manipulating with such big numbers. So what I was recommended to do and what was actually possible is to use Python. Yeah, so there is this rule of 1 minute, 60 seconds that your program should spend at most 1 minute at any problem to run. So while it's easier for C++ to fit into such a time limit, it's definitely usually should be possible to do with Python too. However, this is not my way. I will not use Python in Project Euler. At least I think so. So what we'll have to do instead is we'll have to somehow use arbitrary precision arithmetic in C++. What is possible is to write your own class for working with such numbers. However, there is some prepared solutions. For example, there is a package called GMP. So today we will start with including GMP. First of all, you need to install it. And to install it, I used VC VKG. So I cannot make this text bigger, so if you're watching this video right after it's uploaded and it's low quality, you'll have to wait. Yeah, what I'm going to do is to run my VC VKG executable to install GMP. You may notice that it worked really fast, and this is because GMP is already installed. So I'm not installing it from the beginning, it's already installed. Also, you will need it's called pkgconf. This is something which is written here. I don't know what it is actually, but it helps CMake with working with GMP. So here I will write install pkgconf. It is also installed, so I am prepared. Unfortunately, I spent a lot of hours on this problem, but luckily you don't have to see how I struggled, so everything is ready. Also, to work, to make CMake work with VCPKG, you will need to change your CMake settings. I had to change two settings. First of all, I had to set CMake toolchain file so that it is provided by VCPKG. So this is your folder where it is stored, and this is relative path. The second thing, I believe it is here, and it is CMake executable. So default CMake executable provided by Visual Studio is unfortunately either very old or simply handicapped. I don't know, but it doesn't work. I had to change it. So with all that in mind, you actually have here the full instruction how to use it. So let's copy it. Can I copy something? Let's try. Maybe I need to right click it and then, yeah, it worked. So we need to find package pkg-config. Then I check them, and here I need to paste it here and replace main with the name of target that I'm going to use. Okay, this finished. This worked. And I knew that it will work because I spent a lot of time and had a lot of sets of strings which didn't work. So now you can just write your program as usual, but if you need, you can include something like gmpxx.h. After you've done it, you can simply use mpz class, and it works like an int, but a very long int. Okay, let's have a string, find dance. So here I'd like to have vector of mpz ints, mpz classes, numbers. And actually, I will not write this. Instead, I will write while mpz class temporary, and while in temp, I push back it into the numbers. And then I print find answer of this. And also there is a parameter of first 10 digits. So let me just write int k, which will contain the number of digits. So as an input, we give, first of all, number 10, and then all these numbers. Okay, with that in mind, we simply have a vector of numbers here. So what we do here is, first of all, we start with their sum, which is initially 0. We iterate over all numbers and add them to the sum. Finally, here should be numbers. And here what do we do? Let's look actually what sum is able of. We can get string, and it returns a string. And then we print substar of 0 and k. And we also need to give number k. And give it here. Okay. And we need to return it. So let's see if it works. Oh, it's unfortunate. I again messed with the numbers. So let's rerun the 12th program. because I don't want my input files to corrupt each other. Let's see. Yeah, it's just 10 digits. Let's check them. Yes, it works. Let's continue. Problem 14. It's Collat's problem. Which starting number under 1 million produces the longest chain? So as far as I know, while it can grow a lot. Okay, let's actually check that it doesn't grow a lot. So we create a new file. We add it to CMake lists. We don't need this line anymore because we don't need long numbers. Okay, and here we simply print its length. Okay, what is under 1 million? Let's suppose that it is strictly less than k. So let's go from 1 to k. Let's strictly less. So what is the chain? Chain is something that ends with 1. So we store starting number, which is 1, and length, which is 0. So we calculate new length, which is find length of I, and if it is greater than before, we replace them. And we replace the starting number with I. And we return starting number. We need to find length. To do that, we simply simulate this process. So while n is greater than 1, or we do some iteration, and we return their number. So pretty easy. How do we calculate the iteration? So if n is odd, we recalculate it as this number. Else we recalculate it as this number. Okay. Finally, we only need to provide it with number 1 million. And let's run it. Okay, let's include chrono. I don't believe it. I don't believe it. What? No, 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 no. This is impossible. It can't be. Okay, let's Oh my god. Stupid bugs. Again? What's happening here? Ah. Yes, 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 yes. Okay, now it supposedly works. Let's replace with 1 million, although it won't change anything, and submit it. Ah, this is because this is an int. Okay, let's also make some checks that nothing breaks. So, for example, here, let's also check that we have no overflow. So how do we do it? We say that if m divided by 3 is not n, we throw an exception. Let's see how it works. It stopped working. What? I believe that in debug and in release I have different versions of CMake. What's wrong with you? Ah, I am dumb again. Okay, now we have an overflow, definitely because n was quite big number. So how can we fix it? Let's just use long here and hope that it is enough. And I think it should be enough. Yes, now it was enough. And we get this number. Actually, will it work in release if I replace it with int? No, but it doesn't say where the problem happened. Yeah, so it doesn't quite say the meaning, the core of the problem. This is because by standard, I believe you cannot have uncaught exceptions in C++. So if you throw an exception, it should be caught somewhere. And in my case, the exception was able to reach main and still was not caught. So let's move back to long. So my program is ill-formed, no diagnostic required. Ill-formed, no diagnostic required. Something like this. You can Google these 5 symbols. They are really depressing sometimes. Okay, it spent 200 milliseconds, which is still much less than 60 seconds, so we are fine with it. Let's go with problem 15. Starting in the top left corner of a 2x2 grid and only being able to move to the right and down, there are exactly 6 routes. How many such routes in a 20x20 grid? So this is a standard problem based on dynamic programming. Let us implement it. So we copy code from here. We close this and this and this and this and this and this and this. And here we add the next executable. We replace this. We create an input file with soul number 20. Actually, let's start with 2, which will give us 6. And here we print findance, which might be long. So let's go. So this is a dynamic programming problem. And for which, like, so if we start here, then for each point, we calculate the number of routes from the beginning to this point. Yeah, so first of all, since we have k by k grid, we have k plus 1 times k plus 1, actually the number of points. Also, let's say that the beginning is 0, no 1. And let's go through all. So what I also would like to do is to Okay, let's do it with ifs. I don't mind actually. So if I equals 0 or j equals 0, we will actually just say that dp ij is 1. So this is not needed. Else, is it just simply choose number? Yeah, I believe this is just choose 40, choose 20. Okay, I don't care. We will just use the stupidest formula, which is to say that if we are in some point, we could come here from this point or from this point. There are 2 cases and they are counted in this TP. Finally, we print TP.back.back. or simpler just dpkk. So we see here we see here 6, and if we replace it with 20, we see this number, which is definitely it fits in 64 bits. So we can simply print it. One possible optimization would be to only consider such pairs where I is greater than j, for example. In this case, we would only have to calculate half of these numbers. But as Igor Gorbachev says, unnecessary optimization is sometimes worse than no optimization at all. Well, always. Always worse than no optimization at all. What is the sum of the digits of this huge number? Okay, this is one more problem which requires our long arithmetic. Let's do it. So here we use gmpxx.h, and it is not available actually because we didn't link this library to this target. Actually, this file right now does not belong to any target at all. So we have to create new text file 16, where we just put number. Let's for now put 15. And here we create the 16th target and we link gmpxx to this target. We change the number of targets we are running currently. Now it works. Yeah. Yes, it works. So we only need to create an NPC class n, which is 1. Actually, let's do like this. I take this class, I move it by k, I pass it back to NPC class, because it will be something like NPC expression instead of class. Then I take toString, get str. Yeah. After that, we need to sum all its digits. Since this is only 2 to the power 1000, the sum of the digits shouldn't be big, so it will fit in int easily. So we just say s equals 0 and s plus equals c minus 0. Return s. Here we can use int. Here we can use int. Fine. Let's see what it says. So it should say 38, 26. 26, yeah. Now we replace it with 1000. And it gives us the answer of 1366, which is easily a correct one. Let's go on. If the numbers 1 to 5 are written out in words, then there are 19 letters used in total. If all the numbers from 1 to 1000 were written out in words, how many letters would be used? Okay, I a bit hate this problem. I hate it a bit. Okay. Okay. Okay, let's write a function, I believe, which calculates the length of the number. In this system. And after that, we will think how to use. Actually, the usage of this function is quite clear. The problem is with writing the function itself. So here, only all we need to do is iterate through all numbers from 1 to 1000 and calculate the number of letters in each of them and add them up and return the sum. It's always also int, I believe. Okay, so we need to write the function letters. So first of all, if n equals 1000, we return 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We return 11. Okay. This is not needed. Otherwise, actually, let's divide it into two parts. Like int left is n over 100 and right is n% 100. So, and also int between, it stands for these letters. So if we have both left part, which is some hundreds, and the right part, which is some units and tenths, if we have both of them, then we need to use AND. So this is like left and right, and if they both are here, we need to use 3, else we need to use 0. And then we return hundreds of left plus between plus tenths and units of right. So now we have to write two functions. To write this function, we need actually only this number and 100. 100 is simply 7 letters, so we need to return 7 plus tens and units of n. Now let's write the function tens and units. And to do it, we also divide it into two parts. So int left equals n over 10 and right equals n% 10. Okay. So first of all, if left equals 1, then we have some separate array of values, which I believe I will just write in using strings. So we use like, let's just write them so we don't make a mistake. 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have this array, and let's start it with 10, just in case. And here we return 11 right dot size. Nice. So this was kind of easy. Otherwise, we just need to return tens and units separately. We'll return like tens of left plus units of units. So units is straightforward. We simply need to write all numbers from 1 to 10. Let's do it. So for 0, we don't write anything. For 1, we use 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we return unit n dot size. And for tens, we use here nothing, 10, 20, 30, 4. Actually, is it 40 or 40? I believe it should be 40. Maybe we have a sample here. Yes, it is without u. 50, 60, 70, 80, 90. Is it 2 times 2? I don't know. I don't know. I believe it uses 2 too. 2 t's. Oh my god. No, I should use only 1 t. Hmm. Okay, do we believe that it is correct? Do we believe that it was correct? Of course we believe that it is correct. What? Why didn't it print anything? $23? Maybe here we should have 2 tens, 2 t's. Do we use 40 is here, so this cannot be wrong. So how did I fail? I don't understand how it's possible. 10, 30 maybe. I don't know how was I able to misspell 30. Maybe I don't know how long 1000 is. So again, let's check 1000, which should be 11. 11 letters long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, this is definitely 11. $54? Stop, what? Why 54? Why 54? Why 54 is too much? Ah, n equals 0, then return 0. Yeah, it happens. Sad when I get such kind of bugs, but whatever. Okay, problem 18. Find the maximum total from top to bottom on this triangle. So this is one more dynamic programming, which is still quite dull and don't really I shouldn't really change old files. I need to create new ones. Okay, here we go. Cancel. Solve problem. 18, 18. New target. Replace the target. Okay, so we read. I don't know. Okay, let's read it interactively. Interactively? I don't know. So what I mean is we will go on. So if we have read the number 10, we in place back into v.back.push back temp, and then we go through 1 to v.size. We in place back a new number. Actually, it should be vector vector in here. And we read v.back.back. And after that, we calculate this answer. And to calculate this answer, we simply let's go from bottom to top, I believe. So how to go from bottom to top? We take this answer and we go through, let's say constant n equals ans.size, and we go through n minus 2 to at least 0. And for j from 0 to I, and here we say that ans ij plus equals max of what? Do I need to maximize it? Yeah, I believe I need to maximize it. Edit max, and since I use max, I need to include algorithm maximum of ans I minus 1, plus 1 actually, j, and ans I plus 1, j plus 1, and return ans.front.front. Okay, let's go. No, it doesn't want to work because this failed. Ah, I believe I understand. Else break. Okay, now it was fast, and it gave me some number 1074. Correct. Problem 19. You are given the following information, but you may prefer to do some research for yourself. Okay, let's assume that we ignore it. How many Sundays fell on the first of the month during the 20th century? Since I lived in the 20th century, I should have known this, but unfortunately I forgot. Okay, let's assume that I don't want to use the prepared library of date time in C++, although it's not the worst thing possible. I believe the information which is given in the statement is kinda enough. So let's assume that we always start. Okay, let's give these 2 years as the input. We also create the new project. We update the new project here. We copy the code here. We replace the input in the output file. So here we read 2 years and we find the answer. Sorry for Gorbachev, but I didn't use half intervals or semi-segments, I don't know. I used just a segment. So here I will go from B to E. Actually, I will have constant beginning, which is 1900. And I start with b plus 1. Okay. Here I have b and e. Here I have sum, which will be returned. And also we store our current day of week, which is 0, and I start the week with Monday. Okay, all of this should be simply replaced. It shouldn't. Oh, this is sad. This is sad. This is sad. Okay. So, let's calculate the Sundays. We do something, and then if I is at least b, we add all the Sundays to the sum. So let's go. We iterate over all months. What do we do? First of all, if day of week equals 6, we add 1 to the Sundays. Okay, after that we need to add some days. And what we do here is we say that day of week is day of week plus days percent 7. So let's calculate days. This is simply month of month, and if bisextile of year, which is I, then, and if we have the February, then we add 1 to the days. So we have two functions, length of month and bisextile. Sorry if I destroyed your ears, but I had to do this. So we create vector of months, which is 31, 28, 31, 30, 31, 30, 31, 31, September, October, November, December. Okay, and semicolon, and full bisextile of year. I don't actually need the instruction. I know that if y percent 400 or equals 0, or y percent 100 is not 0, but y percent 4 is 0, then we return true, then else we return false. So let's go. This is 171. Does it look like the truth? So let's multiply it by 7. Yeah, by 7. It's something like 700 plus 490. So 1190. So 1190 is something like 1200, and 1200 is definitely near the number of months in 20th century. So let's try and return this. Okay, this was inevitable. Problem 20. Oh, I like this problem so much. We all again use our library GMP. N factorial means this huge number. Find the sum of the digits in this number. We simply take the code from this problem and we just make some adjustments. What are the adjustments? First of all, in the input we use 100. Here we replace this thing with this thing. No. Should I have written it like this? Oh, there we go. Okay, I believe that's it. That's simply it. We just run it and it gives the correct answer. No. No, 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 no. I forgot about this. So we fix 16th and then we run the 20th. 648. Why is it so short? Okay, let's blindly believe this output and I simply print it. There we go. Problem 21. Let's d of n define as the sum of proper divisors of n. Amicable. What is amicable? Or amicable?
Amicable.
Amicable. Okay, I knew that they are дружелюбные in Russian, but I didn't know this word in English. Evaluate the sum of all the amicable numbers under 100,000. 10,000. 10,000 without 100. Okay. If these input files begin to seem like a mess, seem to be a mess. Under means that we use strictly less than 10,000. What? What is transaction? So here we go. We read n. And we need to find all pairs of amicable numbers. This is not really hard. So we'll go through all numbers and check if it is amicable. So let's write a function amicable. And to write it, we need to check that. Yeah, let's find the sum of all divisors, not on the proper. I believe we can just do it in linear time. So actually, you can calculate the sum of divisors in like square root of n time, but let's just do it in linear time. I believe it's still fast enough. It will take like second. So we return d of n equals n. No, int e equals d of n. Return e is not n, but d of e equals n. To calculate the number d, we go through all numbers from 1 to n, and if n% I equals 0, then sum plus equals I. Actually, we need the sum of all amicable numbers, so here we needed to say ans plus equals I instead. So also okay, I believe that's it. So we put 20, 20, 20 here definitely. Oh no, I did something wrong. So I need 21 here, 21 here. And in CMake lists, I need to add 21. Here, 10,000. So let's see how long it takes. 21, I said. About a second. I think it's about a second. Yeah, something like this. And the answer is 31,000. Okay, I don't have any reason to not believe it. Or do I? Okay, let's check if something is amicable. Actually, I'm not really sure. So 220. 1. Yes, fair enough. So we return this number and we're happy. We are happy. We're happy. Using names.txt. Right click. No, I will not use right click and save target as. I will hold Alt and press it using my letter Alt, key Alt. So it just saves as. Nicely. Mm-hmm. This is actually, I don't like it. I don't like it because in C++ there aren't really convenient ways to do it, and I will need to write some cycles and something like this, but I will. This is fine. Okay. So we read string s and we find ans of s. How do we find ans of s? Okay, first of all, if I multiply it by something like 5,000, it is still not much. Okay. So how do I find ans? How do I find ans? First of all, I need to parse it into a vector. Okay. Then let's actually start with this one. I actually don't like it, but it's fine. So vector string v. So for char c from s. So if c equals a quad or a colon, then this means that we started the new name. And if we started a new name, then we need to push it. How do we push it? So if v dot empty or v dot back dot size not empty, the back is not empty, we need to emplace back. Then we need to push this symbol. Actually, else we push this symbol. And here I can start with 1. Then while v dot not empty, but v dot back dot empty, we pop back and we return v. So this doesn't sort, but this parses all these symbols into one huge array. Okay, after that, I need to do what is said here. Begin by sorting it into alphabetical order. So let's do it. Sort p dot begin, p dot end. Then we go through all items in this list. Okay, int index equals I plus 1. So if index equals 938. Let's actually print it. Okay. Then let's add index times alphabetical value of pi, and we return sum in the end. Let's find the alphabetical value. This is simply for char c from s, answer plus equals c minus a plus 1. Okay, sounds legit. 22, 22, 22. Let's go. I needed to put it into my input file. So let's just rename it to input 0022.txt. What? What is that? This is a quote. Why is it a quote? This is a huge blunder from my side, but I needed to write it like this. Now it's Colleen. What? What? Why is it Colleen? What is the first one? Ebbe. Maybe I needed to sort with 0 index. So like this. What? Are there two colons? Are there actually two colons? Can I remove it from here? I cannot remove it from here. What? I cannot read this text? Really? I can press Ctrl and then it disappears. Great. Okay, there is actually only one colon. And is there this colon? Yes, there are both colons. I needed to print I, of course. Okay, now it should work. Yeah? Yeah, now it works. Okay, so we believe that it is the correct answer, which is 871 million. Fine, fine, fine. Let's believe that it doesn't overflow. And we print this number. Problem 23. Okay, the perfect number, I know what is a perfect number. A number is deficient if the sum of its proper divisors is less than n, and abundant if it's greater than n. 12 is the smallest abundant number. The smallest number which can be written as the sum of two abundant numbers is 24. It can be shown that all integers greater than this can be written as the sum of two abundant numbers. However, this upper limit cannot be reduced any further by analysis, even though it is known that the greatest number that cannot be expressed as the sum of two abundant numbers is less than this limit. Find the sum of all positive integers which cannot be written as the sum of two abundant numbers. Okay. Okay, let's rewrite our problem as follows. Given is this number 28,123. Given this number, find the sum of all numbers which are at most this number, and which are not expressible as the sum of two abundant numbers. Okay. Can the sum be large? The sum can be something like this squared over 2, which is 900 million over 2. So not much. Okay, we store it in int. So let's start with finding all abundant numbers. So if abundant of I, actually I just say that AB I is abundant I. Then I go through all numbers which are at most n. Actually I can do it in this same array, in this same cycle. Okay, so I go through all numbers in j equals 0, j is at most I, or at most I half, but I will use it at most I, plus j. So if abundant, also let's stop when necessary. So if abundant, if AB of j and AB of I minus j, then sum of abundance is true. And then we just break. And if not sum of abundant, then sum plus equals I. Well, let's finally write a function abundant. And this function simply checks that the sum of proper divisors of n is greater than n. And to find this d, we do the same thing that we already did with the amicable pairs, which is we go through 1 to n, and if n is divisible by I, plus sum plus equals I, and return sum. So we have actually two parts. The first part is this one, which is called pre-computation, and it works in n squared time. And this part works in also n squared time, so total it is much less than a second. It is like, okay, second. It's just second. No, it was not second. Because I didn't change the file. I should have changed it here, here, and here. Still, it can work fast. Oh, it spent more than a second, really? No way. 45? Really? No way. Ah, of course. Okay, now it's more like the truth. And it worked. Problem 24, lexicographic permutations. Actually, let's solve this problem and I stop. Let me prepare everything. Problem 24. Input 24. CPP 24. Save 24. 24 and 24. Okay. Permutation is an ordered arrangement of objects. If all of the permutation are listed numerically or alphabetically, we call it lexicographic order. What is the millionth lexicographic permutation of the digits, these digits? Okay. Actually, I could have done it more proper way than I will. I will simply run million. So actually, if you have a permutation, you can find the next one in linear time. So in O of n. So you spend 10 units of time and you find the next permutation. So if it were trillionth permutation, it would worth it that I write some fast algorithm. But in this case, it's simply not needed. So I read two numbers, which is million and 10. Million and 10. Here I construct this first permutation. And I find the next permutation n minus 1 times. There is an algorithm which does it. And finally, I write the permutation. Actually, let's make it string. Okay. So I did something, and this is my permutation. Okay, this was nice. The problems were unfortunately stupid, dull, not really useful for me still. Maybe we will find some adamant or brilliant in this flow of dull problems. Until then, thank you for watching.